Welcome, everybody. So everyone's heard of these initiatives, so now I'm going to talk a bit about some of the details of what we've been implementing at the survey in the last couple of years. I thought it would be good to start with a bit of a historical perspective on where we've been for the last 10 years and where we're trying to go. So prior to fiscal 23-24, so field season 23, we had an operating budget of about $790,000, and that was for the entire survey. So those of you who are in exploration, you know that that's very limited amount of money to work in Labrador. So it really limited our ability to do much work independently in Labrador. So we could basically afford one mapping project and associated mineral deposit project. So we did a lot of collaborative work with that. But our real ability to work in Labrador was because we partnered with our federal surveys through GEM, GEM2, GEM Geo North, and we continue to partner with them. And some of the outcomes from those partnerships you're going to hear about later today. But this support allowed us to avail of about $10 million in geophysical surveys since 2009. And we continue to submit requests to the GSE at every funding opportunity. So the last request we put in was for the Makhovik province. And those that know my history know that the Makhovik province is really dear to my heart. And I really wanted to see geophysics going from the coast where we have all the exposure into all the areas where people are exploring so that we can make some real ties from the geology to the geophysics. That is expected to be out today, and the talk later on this afternoon will talk about some of the benefits of doing boots on the ground follow-up on these geological surveys. We recognized that we needed to update bedrock mapping, superficial sampling, and mineral deposit research in this area, in these regions, in Labrador in general. So you might, if you're not familiar with public geoscience, you might want to know, why do we have to do this? Well, modern mapping is done at 1 to 50,000 scale. Some jurisdictions like BC are even more detailed than we are. And the reason that you need to do this at this scale, and you'll see the coverage that we currently have at a modern scale, is because there's been advances in a lot of different techniques. So things that have changed in the last 40 years since much of Labrador was mapped are chemical analysis, geochronology, isotopic systems. We also have had changes in models. So for instance, Voisey's Bay, the type of rocks that Voisey's Bay was formed in, at the time that Labrador was mapped, it wasn't known that nickel-copper magmatic deposits could form in that kind of environment. So the people who were mapping wouldn't have even thought it was possible that this was something they should be looking for. Another good example is lithium pegmatites. Again, we knew about it, but it wasn't considered economic, so it wasn't something that people were really making strong notes about. And there's lots of different examples of that I can point to. And another really key thing is that mapping styles have really changed in the last 40 years. So there used to be a push towards mapping structure versus lithology or rock type. Now we prefer, and mineral exploration prefers to see lithologies because it tells you a lot more to know the type of rocks rather than the deformation history of that rock. Another big one is protolith mapping, so that's what the rock was before. Historically, people would map a granite that had even the slightest amount of deformation as a gneiss. And from an economic or mineral exploration point of view, if you see gneisses all over the map, you're thinking, oh, that's not great, when really it is just a slightly deformed granite. So things like that have really changed the nature of mapping. One other thing I really like to talk about when I get a chance is the scale of Labrador. They call Labrador the big land, and that is very, very true. All of these little boxes in yellow are 1 to 250 scale. So I've kind of compared Labrador, which has way more boxes than Newfoundland because it's a much larger land mass. And so much of the mapping is kind of at 1 to 250 or 1 to 100,000. So you'd have one team in that whole area doing that map over the course of a couple summers. Inside these, I've now overlaid the 1 to 50,000 scale map. So this is what we're trying to get to. These are the scale of maps that we want to be producing in Labrador. And it's basically a 25 kilometer by 25 kilometer grid. So I laid it over in St. John so people can have somewhat of an appreciation for how much ground you have to cover as a mapper. And so like essentially it's the Northeast Avalon and would be one map sheet. A lot of it's water. And it would take, somebody for a full summer to do that because you can only hike so far. So each of our geologists are only able to accomplish one of these map sheets a year. Following up just on the geophysics that's been flowing since 2009 is 105 map sheets. So there's a lot of work for us to do. So we recognize this, and we recognize that we didn't have current staffing or funding to be able to follow up on this, and thus we put in the new initiative that was successfully funded for 5 years, and it allowed us to address the specific needs of working in Labrador. And so it improved our overall operating budget to $1.84 million, and we started a full field season this summer with 3 new project geologists. So we chose areas specifically that we had already foundational data from, because we had been working in the Hopedale Block in Bukovic Province off and on since 2017 with some of these GEM projects. We had really good baseline data, and that's why we selected to put people into these, because we knew questions that we could address, that we had the compilations complete so that people could hit the ground running and know what they were targeting. So things like major tectonic boundaries. From a mineral deposits point of view, major tectonic boundaries are where fluids go. If fluids are going there, there's a high potential for different mineralizing systems. So we wanted to put somebody boots on the ground looking at that. We also knew there was an ice stream through the area, and we had till chemistry with our partners at the GSC, going right from the ocean into essentially the line where we put our new terrain scientists. So we were going to be able to build on that data set and make it more meaningful. And we also knew abundant mineral occurrences. And John touched on this, so I won't say anything too much. And I also noticed the lack of a timer up here is probably a bad thing. It should start waving when it's been 15 minutes. Anyway, so Ludo is, again, mapping this boundary. A really important feature, whether or not, where it lies, where the Churchill boundary lies. So he'll be doing that for the next couple of field seasons. Marina, again, is looking at the Florence Lake and Hunt River greenstone belts in detail, and working with David, who's doing the bedrock mapping. So again, real collaborative approach to our project planning. Rebecca Sterling, as I said, she's doing the till chemistry in the region and looking at ice flow and building on the data sets that already exist. So this is the outline of projects where we're working. Obviously, we've got a lot more to do, but I'll just briefly mention the other projects that aren't part of that or weren't part of that initiative. We have David, I said, who is mapping in the Hopedale Block, so he's got a good 30 years of mapping there. He'll talk next about some of his initiatives to help with the mapping. I started a project working in the Harp Lake Intrusive Suite. If anyone knows the map of Labrador, it's the giant gray blob in the middle that I know it just can't be a giant gray blob. So I started looking at that. And Tim Van Ostren, John mentioned this, is published the Still Lake Group geological maps. I think that was 26 1 to 50,000 scale maps, so a massive contribution, and is working on the 11 maps for the Ashwanapi complex. Juji is working on rare earth mineralization, so she'll have some exciting results coming out of that in the next few years. And Sarah Hashmi, although she wasn't in the field this year, she does have several publications that have come out with regards to her data looking at humus and till in the Port Hope Simpson area. So the next initiative is the Critical Mineral AI. We put all the really hot acronyms into this title. Remote bedrock and mapping prospectivity thing. So again, essentially we were targeting regions in the province with high prospectivity for critical minerals and using innovative geoscience technologies like AI and remote sensing. So we had $3 million that was approved in November 2023, and this funding is until March 2025, and we're requesting and hoping to have more longer-term funding. So what was our goal? Well, essentially to have geological proxies that we can then feed into a machine and end up with prospectivity maps, and maybe therefore target more effectively some of those 110 maps that we know we have to look at in Labrador, and prioritize regions that may be more prospective than others. And essentially, we're talking about machine learning. We're not making chatbots. So that's really where we are, where we're trying to build algorithms. And it's really computer and data intensive. So we recognized immediately that we were going to have a problem with the data aspect because there's limited regional data in Labrador and in much of the island. And we wanted to illustrate this by doing a test case in the Bayvert Peninsula that we ran this summer with Burkay Ursus. Bayvert, I felt, was one of the areas in the province that had the most data-intensive set of data that we could feed into a machine learning algorithm. And the idea was that you could take all the layers, this is what you're supposed to do, and then feed it in and get some perspectivity maps. And so we did things like buffer the faults with relationship to the mineral occurrences. And it was interesting, but in the end, there was not enough data for us to produce anything at all meaningful. So it did just reiterate in our minds that we really needed to get more data, in usable format for us to actually be able to start applying these technologies. So we recognize that to be successful, we need new project geologists. We did not have capacity with the people currently employed to take on any additional projects. And we needed to look at novel ways to interpret geophysical data. We need to acquire additional remote sensing data for prospective areas and to acquire additional conventional data. So this is one of my favorite projects. So one of the things that I've always been a fan of is some of the work that Lyle Harris does out of IRNRS. And we had the opportunity to hire a new geophysicist, Ronak. And so the first thing we did was work to collaboration with Lyle to have her be trained on some of these processing techniques. And these are essentially ways of making maps that show different structural levels of the crust so that you can see or hopefully interpret the structures and find out whether these are deep structures. And deep structures are always important if you're looking for mineralizing pathways and mineralizing systems. So she's been producing these maps for us, and it has helped all of us with our interpretations. So a big shout out to Ronak for that. David will be talking about this next, so I don't have to touch on it at all. But we were looking at getting some more satellite-supported data for our projects. And finally, one of the projects, I think it's finally, that we're also working on right now is led by Zachary Adam, and we're looking at making a new regional geology map for the entire Labrador. The previous edition was published in 1997, and Zach informed me that he wasn't even born then, so I was motivated to get started on that project. And so some of the additional data that I speak of that we're collecting is geochronology, isotopic systems, both new systems that we haven't really gone into and traditional ones, a lot of geochemical reanalysis of existing samples and microanalysis. Some of the additional research projects that we've taken on is, again, I touched on the machine learning of existing airborne geophysical data, modifying some existing algorithms for models of nickel, copper, cobalt mineralization, comparing and integrating algorithms with these new maps that we're producing. And we were working on developing and testing algorithms for platinum group mineral elements associated with ophiolites. So I will close. John touched on this, so I guess I should have not touched on it, but we were successful. This is the federal government critical mineral initiative, and we were successful in getting, almost $1 million from them to complete 2 surveys. The one north of Nain, there will be a coming GEM project in that area, so we are hoping that we'll have that survey ahead of that GEM project, which is both bedrock and superficial mapping around Nain. Oh, I'm done now.